For decades, the world believed that the greatest battle of the space race was being fought over the moon. While the United States was pouring billions into the Apollo program, chasing the dream of landing the first human on the lunar surface, the Soviet Union had set its sights on a destination far more mysterious and far more terrifying. A planet hidden beneath an endless blanket of clouds, a world no telescope could truly reveal, a place that would eventually earn the nickname Hell's Twin. This was Venus. Throughout the 1960s, almost no one knew what lay beneath its thick atmosphere. Scientists couldn't tell whether its surface was covered with oceans, dense jungles, endless deserts, or something humanity had never imagined before. The uncertainty made Venus the greatest mystery in the solar system. And for the Soviet Union, solving that mystery wasn't just about science. It was about winning the Cold War. Every successful mission was proof of technological superiority. Every failure was hidden from the world. Space had become the ultimate battlefield, where prestige mattered as much as discovery. When US President John F. Kennedy publicly promised that America would land astronauts on the moon before the end of the decade, Soviet leaders knew they needed an achievement just as extraordinary. If America could conquer the moon, then the Soviet Union would attempt something even more daring. It would send a machine into the most hostile world known to humanity. At the time, Venus seemed surprisingly similar to Earth. Both planets were nearly the same size, and both orbited relatively close to the Sun. Many scientists even wondered if life could exist beneath Venus's mysterious clouds. But there was one enormous difference. Unlike Earth, Venus was completely hidden behind a permanent layer of thick clouds. No telescope could see through them. Whatever existed on the surface remained invisible. To Soviet scientists, that mystery was an opportunity. If they could become the first nation to reveal what lay beneath those clouds, it could rival, or perhaps even surpass, the significance of landing on the moon. Some even imagined finding vast oceans, dense forests, or perhaps evidence of alien life. Driven by those ambitions, Soviet engineers launched one of the most ambitious planetary exploration programs in history. It would become known as the Venera program, named after the Russian word for Venus. The mission was unlike anything attempted before. The probes had to survive conditions that scientists could only estimate. They knew Venus had an atmosphere, but nobody knew how dense it was, how hot the surface might be, or what kind of pressure awaited below the clouds. So the engineers prepared for the worst. Each spacecraft was built stronger than anything previously sent into deep space. Every component was designed to endure crushing atmospheric pressure and an unknown environment that no machine had ever experienced. But there was another challenge. The Soviet Union kept its space failures secret. During the Cold War, unsuccessful missions were rarely announced. If a launch failed, officials often disguised it as an ordinary satellite mission rather than admit defeat. The first attempt came on February 4, 1961. The spacecraft never even escaped Earth's orbit. The mission failed before it truly began, and the world never learned what had happened. The Soviets simply moved on. To improve their chances, they adopted a simple strategy. For nearly every mission, they built two identical spacecraft. If one failed, the other might still succeed. Soon after, two new probes were prepared, Venera 1 and Venera 2. Unlike later missions, these spacecraft weren't designed to land on Venus. Their objective was much simpler: fly past the planet and transmit valuable scientific data back to Earth. On February 12, 1961, Venera 1 lifted off, becoming the first spacecraft in history sent toward another planet. It was a historic moment. But history doesn't always reward courage. Only 7 days after launch, all communication with the probe suddenly ended. Silent and uncontrollable, Venera 1 drifted through space, eventually passing roughly 100,000 kilometers from Venus. Close enough to make history, yet too far to send back a single piece of useful data. Even today, that lonely spacecraft is believed to still orbit the Sun. Years later, the Soviets tried again with Venera 2. The outcome was painfully familiar. Once again, contact was lost before the spacecraft could complete its mission. Another failure, another secret, another reminder that Venus was refusing to reveal its secrets. But instead of giving up, the Soviet engineers became even more determined, because they were no longer trying to reach just another planet. They were preparing to challenge a world that would soon prove to be the most hostile place any human machine had ever attempted to visit. After years of failed launches and silent spacecraft, the Soviet Union realized one thing: simply flying past Venus wasn't enough. If they truly wanted to uncover the planet's secrets, they would have to do something no civilization had ever attempted before: send a probe directly into its atmosphere. In 1966, the next generation of spacecraft was ready. Venera 3 and Venera 4 were far more advanced than anything that had come before. Each weighed nearly a ton and was built in two separate sections. The first was a carrier module that would guide the spacecraft across millions of kilometers through space. The second was a sealed landing capsule, packed with scientific instruments and designed to descend into Venus's mysterious atmosphere. Inside that small sphere were pressure sensors, temperature gauges, gas analyzers, batteries, radio transmitters, and every tool scientists hoped would answer one simple question: what is Venus really like? Unlike future missions, Venera 3 wasn't expected to survive. Its mission was straightforward: enter the atmosphere, collect as much information as possible, and transmit everything back before the planet destroyed it. It was, in every sense of the word, a suicide mission. But even that plan didn't unfold as expected. As Venera 3 plunged into Venus's atmosphere, disaster struck. The spacecraft suffered a critical system failure before it could transmit any meaningful data back to Earth. The mission was lost. Yet despite its failure, Venera 3 still achieved something extraordinary. On March 1st, 1966, it became the first human-made object ever to reach the surface of another planet. Not with a gentle landing, but with a violent impact. Humanity had touched another world for the very first time. The victory was symbolic. The mystery of Venus remained unsolved. 1 year later, the Soviets tried again, this time with Venera 4. Unlike its predecessor, the spacecraft functioned almost perfectly during its descent. For the first time in history, scientists were receiving direct measurements from inside Venus's atmosphere. And what they discovered immediately shattered decades of assumptions. The atmosphere wasn't rich in oxygen. It wasn't similar to Earth's. Instead, it was composed almost entirely of carbon dioxide. A lifeless, suffocating blanket of gas surrounded the entire planet. Initially, Soviet scientists believed the atmospheric pressure was about 25 times greater than Earth's. They even announced that Venera 4 had landed successfully on the surface using its parachute. But later analysis revealed a very different story. The probe had never reached the ground. Long before landing, the crushing pressure overwhelmed its structure. The spacecraft collapsed under the immense force, crushed like an empty soda can before it ever touched the surface. Venus had claimed another victim. By now, Soviet engineers understood something terrifying. The planet wasn't just hot. It wasn't just covered by thick clouds. Its atmosphere itself was powerful enough to destroy their spacecraft. Still, the mission had been a scientific breakthrough. For the first time, humanity knew what filled Venus's skies, but the surface remained completely hidden. Determined to gather more data, the Soviets launched Venera 5 and Venera 6 in 1969. These missions weren't designed to survive landing either. Engineers already suspected that reaching the surface was impossible with existing technology. Instead, the probes were built to descend as far as they could while transmitting data through parachutes. Every second counted. They had less than an hour to send everything before the atmosphere crushed tea. The descent began. Pressure climbed rapidly. Temperatures continued rising. The atmosphere became denser with every passing kilometer. And then, exactly as engineers feared, both spacecraft were destroyed before reaching the surface. 3 missions, 3 different designs, the same brutal outcome. Venus wasn't simply rejecting human visitors, it was annihilating them. But instead of accepting defeat, Soviet engineers reached a bold conclusion. If the atmosphere could crush every spacecraft they built, then they would build something even stronger. Not lighter, not faster, just stronger. The next probe would resemble less of the spacecraft and more of an armored tank, because the next mission had only one objective: survive Venus. By the late 1960s, the Soviet Union had learned one harsh truth. Venus wasn't just another planet. It was one of the most hostile worlds in the solar system. Every probe had been crushed, overheated, or destroyed before completing its mission. But each failure helped engineers build something stronger. The result was Venera 7. Unlike earlier probes, it sacrificed many scientific instruments for thicker walls, stronger insulation, and a reinforced pressure vessel. On August 17, 1970, Venera 7 began its journey. Months later, it entered Venus's atmosphere, but during descent, its parachute malfunctioned. The capsule crashed onto the surface at nearly 17 meters per second. Against all expectations, it survived. The impact flipped the spacecraft upside down, leaving its antenna facing the ground. Engineers initially believed the mission had failed, but highly sensitive receivers detected a faint signal. For 23 minutes, Venera 7 transmitted data from the surface of another planet, the first spacecraft in history to do so successfully. The results were shocking. The surface temperature measured around 465 degrees Celsius, hot enough to melt lead, while the atmospheric pressure was nearly 90 times greater than Earth's. Scientists also analyzed the probe's radio signal, using the Doppler effect, discovering powerful winds reaching nearly 360 kilometers per hour, faster than many hurricanes on Earth. For the first time, humanity understood the true nature of Venus. Still, one mystery remained. What did the planet actually look like? To answer that question, the Soviets launched Venera 8. It carried new scientific instruments, including a gamma-ray spectrometer to study the rocks, and a light sensor to measure how much sunlight reached the surface. Most scientists expected complete darkness beneath the clouds. Instead, Venera 8 revealed that enough sunlight passed through the atmosphere to create lighting similar to a heavily overcast day on Earth. The probe survived for nearly 1 hour while analyzing the surface, making it another remarkable engineering success. The Soviet Union had measured Venus. Now, it was time to see it. The next spacecraft would carry cameras capable of photographing another planet for the very first time. After proving that spacecraft could survive on Venus, the next challenge was simple: capture the first images from its surface. The Soviets designed a new generation of Venera landers, each weighing over 5 tons before arrival. Protected by a heavily insulated pressure vessel and shock-absorbing landing system, these spacecraft carried 2 panoramic cameras to capture a complete 360-degree view. Years of engineering depended on one critical moment. After landing, the cameras activated, but the protective lens covers failed to open. Fortunately, on Venera 9 and Venera 10, one lens cap released successfully, while the other remained stuck. Although only half of the panorama was captured, it was enough to make history. On October 22, 1975, humanity received the first photographs ever taken from the surface of another planet. The images revealed a lifeless world, covered with jagged rocks, volcanic terrain, and a hazy orange sky. There were no oceans, forests, or signs of life, only an unforgiving landscape shaped by extreme heat and pressure. The following missions, Venera 11 and Venera 12, survived on the surface for nearly 110 minutes and returned valuable scientific data. However, both missions suffered the same frustrating problem. Neither camera lens cap opened. No photographs were taken. Despite the setback, the missions provided important scientific discoveries, and Soviet engineers continued improving the program. Their next spacecraft would carry better cameras, and something no mission had ever attempted before: a microphone. For the first time, humanity would not only see another planet, but hear it. By the early 1980s, the Soviet Union had achieved what no other nation had. Its spacecraft had survived Venus, measured its crushing atmosphere, photographed its surface, and revealed the true nature of the planet. Now, the next generation of spacecraft, Venera 13 and Venera 14, would take exploration even further. These landers carried improved panoramic cameras, a soil drilling system, chemical analyzers, a seismometer, and, for the first time in history, a microphone. After traveling millions of kilometers, Venera 13 landed safely on Venus, and exceeded all expectations. Its microphone recorded the first sounds ever captured on another planet, revealing the eerie noise of powerful Venusian winds moving through the dense atmosphere. The lander also drilled into the surface and analyzed the soil, discovering that much of Venus consisted of volcanic rock, providing strong evidence of widespread volcanic activity. Venera 13 transmitted the first full-color photographs ever taken from the surface of another planet. The images showed a barren landscape beneath a thick orange sky filled with carbon dioxide and sulfuric acid clouds. Brownish-red rocks stretched across the surface, confirming Venus as one of the most hostile worlds ever explored. Next came Venera 14, carrying nearly identical equipment. However, one small accident became one of the most famous moments in space exploration. After landing, a protective camera lens cap detached exactly as planned, but it landed directly beneath the soil testing arm. When the instrument extended, it accidentally measured its own discarded lens cap instead of the Venusian ground. Years of engineering defeated by a tiny mechanical mistake. Despite the mishap, the Venera missions had already transformed humanity's understanding. The final step was to map the entire planet. That mission belonged to Venera 15 and Venera 16. Instead of landing, they spent nearly 8 months orbiting Venus, using synthetic aperture radar, SAR, to see through the planet's thick clouds. The orbiters produced the first detailed maps of Venus, revealing enormous volcanic plains, mountain ranges, deep canyons, and giant surface fractures hidden beneath the atmosphere. Thanks to the Venera program, scientists finally understood the true face of Earth's mysterious twin. Nearly everything we know today about Venus, its 465 degrees Celsius surface temperature, 90 times Earth's atmospheric pressure, carbon dioxide atmosphere, sulfuric acid clouds, volcanic landscape, and extreme environment, comes from these Soviet missions. The United States won the race to the moon, but when it came to exploring Venus, the Soviet Union achieved something no one else has matched. It ventured deeper into the most hostile planet in the solar system, and forever changed humanity's understanding of our neighboring world.